talk about using compositions of reflections and we're going to want to know how to identify glide reflections. Okay. We talked about translations as a composition of reflections over parallel lines. We'll talk more officially about that today. And then yesterday, rotations are a simple reflection over intersecting lines, and we'll talk about that more today. If two figures are congruent, there is a transformation that maps one onto the other. If no reflection is involved, then the figures are either translation or rotation images of each other. The two figures are congruent. Is one figure? Oh, I'm sorry. That's a question from down below. I'll pause, let you copy that. So, we talked a couple days ago. We talked about mapping onto each other, and remember, I swung that. I guess it was yesterday. I rotated the one around. And we realized that Bailey was right. It didn't match up. It did it, and so we had to fix that. But when we rotate or translate or reflect, we can map one right on top of the other. Okay? And so the question here is, the two figures are congruent. Is one figure a translation image of the other, a rotation image, or neither? I gotta pause this. So I think I can make it work now. So, is it a translation? What's a translation mean? Slide. So can I just simply take this and slide it over there and match it right up onto that? No. Okay. So no, I can't. Okay. Now, is it a rotation? It's both? Oh, you mean a combination? No, it can't be both. It's either a slide or a rotation, or it's neither. There's one thing I look at, the orientation. Are the orientations the same? Is the 5 drawn the same way? It still looks like a 5 in both of them, right? Unlike if I did this. Now it doesn't look like a 5 anymore, does it? And it's not just a matter of rotating it, or it's been flipped over, hasn't it? So the orientation is backwards. So if they have the same orientation, then there's probably some point in which we're rotating this around. Okay, and if we said that point was right here, and I grab this, and I rotate it around here like this, do I get that? Wait a second.
Maybe if it
Yeah,
with
if it would let me turn it like it's supposed to, as I rotate this around, it would have to maintain that same position with here. As it is, no, it's not both. It's a rotation. Here, look how far away. See that line? Okay. As I rotate this around here, this is a lot further away now, isn't it? Oops. I meant to pick a line. But that's a lot longer than this one, isn't it? See, this 5 has to rotate this way as I rotate around. Okay? And it's not doing it. It doesn't allow me to do that. It allows me to rotate it rotate it, but only about itself. Only here, okay? It won't let me pull this over here, and as I pull it, I keep rotating it around. Okay, which is what it's really doing. I was wondering if she owned it, but she did. Okay? So, if it was here, then it would just be a simple slide. But because this is like this, then I'm rotating it around there, okay? So this is a rotation, okay?
Because
It's harder to see, it'd be easier with, I might as well pause this because you can't see it on the screen. And look at that, her and I agree. The orientations of these congruent figures do not appear to be opposite. So one is a translation image or a rotation image of the other. Clearly it's not a translation image, so it must be a rotation image. Okay? And this goes right back to this original statement up here. If two figures are congruent, there is a transformation that maps one onto the other. If no reflection is involved, then the figures are a translation or rotation. And so this statement here says the two figures, oh, sorry. I hit my marker. It says the two figures are congruent. And so that goes right back up to the top. Since they're congruent, it's either reflection or it's either rotation or it's a translation. Okay? All right, let's move on. Copy these down. A little bit of this is review. The translation or rotation is a composition of two reflections. The second one is a composition of reflections in two parallel lines is a translation. I don't like the word in there, but I guess that's what they use. Yeah, I would have worded this a composition of reflections over two parallel lines. And then this one says a composition of reflections in two intersecting lines is a rotation. Okay? So the first one over parallel lines, if we this will be difficult. She worked so hard on this. It's really difficult to make, you know how you saw me trying to manipulate that last one. It's really hard to make them do that. Let's just try to do this freehand. If I took this and reflected it over this line, in fact, let's ignore this R, let's just put an L here. It'd be much easier to do, okay? So if I put an L here and I go over these parallel lines, sorry, I'm pausing. Cheating. Come on. So it has to be perpendicular over this line, has to be the same distance away. So we'll say it's there. Somewhere in the middle of that. Oh, yeah, that doesn't matter. So here's that L, okay? Now if I reflect that L over this line, oops, come on. When it's recording, this just does not react well. I think it's the speed of the computer. So we get this, okay? It looks like I lost a little bit of length of my, probably in this one here, in my L, but, now this and this are the same figure, okay? Had I drawn it well, it would have been. I got started up here, and it's translated down to here. So by reflecting over parallel lines, just like we talked about 2 days ago, we get a slide, okay? We get the translation, okay? If we go over intersecting lines, that's good, you run out of time. If we go over intersecting lines, so let's just draw a picture like this, we'll put an L here. Okay? If we reflect this over intersecting lines, let's stand in front of it so I can, you know what? So I get an L that looks like this. I think I'm a little bit close. Must have held my mirror too close. And then when I reflect that over this line, I get this. Okay? The result is this initial L was rotated around this point of intersection. Okay? So this intersection, the point of intersection, is the point about which we're rotating our shape around. Okay, so the composite reflections, is going to be this, the result in a rotation about the point of intersection. And if this was 40 degrees, any hint on how far this would go?
80 degrees.
Yes. Who said that? Nice. 80 degrees. 80 degrees. It'll go twice as far. Just like, remember 2 days ago, we said that L was going to move how far over there? If this was 5 inches, and how far did this slide? 10 inches, remember? Twice as far. Same thing happens with rotations. If the angle of the intersection is 40 degrees, the acute angle, don't look at the obtuse angle, but the acute angle, okay, is 40 degrees, then the angle of rotation is going to be 80 degrees. Now, direction here, I wasn't paying attention to that, but notice we're going clockwise, which means it would really be a negative 80 degrees, because clockwise is a negative direction, where counterclockwise would be a positive direction. And that all depends on which line did I reflect over first. Okay? I'm going to turn this to red. And if I took this L and reflected over this line here first, I get something like bear with me here. Something like this. Now if I reflect that over this line, I get something like this. Now I've rotated this way, didn't I? So by changing the order in which I reflect over the lines, it changes the direction of the rotation. Okay? It's still going to be 80 degrees, but now it's counterclockwise, so it's a positive 80 degrees. Where up here, when I went over this line first, and then the next line, I'm going this way, my rotation was a clockwise rotation, made it negative. Okay? And then the last one we want to talk about is if I have this line and this, this L, these together. Okay? Now this line and this L, and I have this vector. Okay? A glide reflection. This is the last one. Get this written down. The glide reflection is a composition of a slide or translation, same thing, and a reflection. So this can be done with 3 reflections, because the translation can be done with 2 reflections. Okay, and so if I want to if I want to perform a glide reflection, that's what I'm trying to say, then I have to translate this by this vector, okay? And so I'm going to take this one from here, I'm going to slide it down here to there, okay? And so that puts me in this position. Right? Then I'm going to take this and I'm going to reflect it. Oh, reflected the wrong one. Oh, well. Reflects it over this line, so I end up with that. So my result is this. Let me flip this back up. So I started here. Green for start. I slid along the translation and I reflected over the line, and I end up with that end result. Okay? What's my orientation on this? If I go along the back edge of the L, and if I do that over here, I start at the top and went down to the foot. So if I start at the top and go to the foot, what's true about my orientations? Are they the same or different? They're different. As I read this L from the top down and over to the end of the foot, I go counterclockwise, and as I do the same on this one, I'm going clockwise. So the orientations are different. And that's what that reflection does at the end of this slide. It reverses that orientation. Okay? And the reality is, instead of a vector here, translating this vector, I could have reflected over these parallel lines to get this. And then when I reflected over this line, I would get this L again. Okay, upside down or reversed. Okay? So, no, we didn't do that, and I don't think they're going to do that to you, so we'll just pretend I didn't say that. All right, now there's one last, that's it for the new stuff. I just want to review these. They put it in a theorem of, they put it in the form of a theorem, but I want to remember the isometries. There's 4 of them. What's the first one? What was the first isometry we learned? The mirror. And what did we use? What did we do? Let me try again. What did we use it for? To reflect. So the first isometry is reflections. And so just real simple, looks something like this, right? Okay. What was the second isometry? A slide or translation. And that looked like this. Okay. And what's the third one? A rotation. And so that looks something like this. Okay? So we're rotating it. We'll pretend our point is right here. We're rotating it about our point. Oh, I don't want to put those on there. Okay? And then the fourth one. I didn't come out and say it yet. What was it? A glide reflection. A glide reflection, we just did one, looks something like this. Okay? Where we reflected over a line and we had a translation. And we'll just show it back to there to show our translation. So we slid along the line and we reflected over the line. We get that. So glide reflection. Now what's special about isometries? Isometries always make the figures congruent. The figures will always be congruent if they're one of these 4 isometries. Other transformations, that's not true. We're going to talk in later lessons, we're going to talk about other types of transformations, transforming a shape into something. That's what we're doing here. We're transforming this shape into something else. But in all of these, they're exactly the same shape when you're done. The ones we'll cover later are not. Okay? All right. So our homework will be 1 through 25 odds. Tomorrow we'll have some review. I will give you some worksheets that will review these 4 lessons. So don't think you just come in tomorrow and do all your homework from today.